Okay, good evening my dear students. Greetings from Made Easy. I am Dr. Vinod. I am here to discuss some of the important questions with respect to GATE 2023. In production engineering, we will discuss some of the important questions related to casting, welding and forming. Okay. So, with respect to casting, welding and forming, GATE examination most repeatedly numerical questions will be asking. So, we will see more numerical questions. Apart from this, we will discuss some of the theory questions also, which will be expected in GATE 2023. Okay. Right. Shall we start, my dear friends? Right. Yes. Good evening to everyone. I think most of them are joining. We will wait for 1 minute. Okay. Most of them are joining. But we will discuss, friends, GATE true questions, right, in production engineering, that is GTQ. So, we will start first with the casting, then welding, then forming we will discuss. Okay, na? Right. Yeah, can you please go through the questions and parallelly you can try the questions, friends. Parallelly you can try the questions, because most of the questions you can try and get the answer. Any difficulties there we will solve parallelly. Okay. You have to try parallelly and you can give the answers also. Okay. So, we will start with the first question with respect to casting. Can you please go to this question, friends? A steel casting of size 200, 110 mm cube, it is a slab casting with a central circular through hole of diameter 5 mm is sand cast. Considering shrinkage allowance of the steel as 20 mm per meter length, because solid shrinkage we are expressing in terms of linear dimension, it is a steel material. It is a steel material it has given. The shrinkage, solid shrinkage has given 20 mm per meter length. What is the ratio of volume of the pattern to the volume of the casting? He is asking what is the volume of pattern to the volume of the casting. Please look at here. First, we will look at this figure, friends. It is a slab casting. I am going to draw the figure. It is a slab casting. Okay. So, the dimensions are 200, 100 and 10. It is a circular hole. Throughout this thickness, through hole is there, and whose diameter is 5 mm. Diameter of the circular hole will be 5 mm we are going to consider. Diameter of the circular hole. This is a casting. Dimensions of the casting has given this one. And is mentioned that the shrinkage is 20 mm per meter length. For 1 meter length, the shrinkage is how much? 20 mm. Right. So, if you look at closely, right. So, if you consider, friends, for 1 meter length means indirectly for 1000 mm, the shrinkage will be 20 mm per meter length. 20 mm per meter length. Now, we can find out for 200 mm how much will be the shrinkage. For 200 mm, the shrinkage will be how much? It is 4 mm. Shrinkage will be how much? 4 mm. Similarly, for 100 mm, how much will be the shrinkage we can consider? For 100 mm, the shrinkage will be how much? 2 mm. 2 mm will be the shrinkage. Similarly, for 10 mm, how much will be the shrinkage? Please think of this is 1 mm, sorry, 2 mm, it is 2 mm. So, for 100 mm it is 2, for 10 it is 0.2, sorry, it is 0.2. It is 0.2 mm. Similarly, for 5 mm, how much will be the shrinkage? It is 0.1 mm we can consider. So, this is a shrinkage, solid shrinkage is always for linear. He has given the dimensions are 20 mm per meter length. General questions we are expecting so far, 2% shrinkage, 1% shrinkage linearly they have given. Sometimes there is a possibility of asking the questions with respect to this also. 20 mm per meter length. For 1 meter length, the shrinkage for the steel metal is 20 mm. So for 200 mm, how much? It is 4 mm. For 100 mm, how much? It is 2 mm. For 10 mm, it is 0.2. For 5 mm, it is 0.1. So with this shrinkage allowance, if you draw this, no, the figure that is for pattern. This is a casting, no. So if you consider a pattern, the size of this pattern you can consider, friends. So there is no need to draw this figure in GATE examination. For your clarity, I am writing, friends, here. Okay. So this is 204. This dimension is 204. This is 102. Next one is what? 10.2. Next one is what? 5.1. 5.1. Diameter is 5.1. So this will be the dimensions of the pattern. This is the dimensions. I can consider this is a pattern. So by adding shrinkage allowance, this will be the dimensions of the pattern. This will be the dimensions of the pattern. Yes, some of them are giving answer also directly. Very good. Excellent. So he is asking volume of the pattern to the volume of the casting is how much? Volume of the pattern to the volume of the casting. So this is 204 into 102 into 10.2. This is a volume. And we can think of a circular hole. I am reducing because he is asking volume, na? So pi by 4, because it's a circular hole, I am removing this one. Pi by 4 d square. Diameter is 5.1 whole square. Height is 10.2. 10.2 I am going to consider. This is volume of the pattern. What is the volume of the casting? 200, 100 into 10 minus pi by 4 d square, diameter is 5 whole square into height is 10. So this ratio, if you are considering, if you simplify, you are getting 0.06. 1.06. 1.06 will be the ratio of volume of the pattern to the volume of the casting. This ratio is always greater than 1, my dear friends. It is always greater than 1. Yes, 1.06, 1.06. Why some of them are getting 1.05? I think you have not removed this. Now the circular hole. See, this is a circular hole. There is no material. On the pattern and the casting also, circular hole, there is no material. We have to remove. Minus pi by 4 d square multiplied by height we have to consider. Please check it. Answer is 1.06. 1.06. Most of them are getting. Hold. Please look at, my dear friends, some of them are saying diameter is 4.9. It is not correct. Look at here. So please observe, some of them are having doubt with respect to this one. And right, the solid shrinkage. Yes, you can look at here, friends. If you consider this is a hole, actually this hole is produced by providing a core inside. Okay. Now this is a solid material. This solid metal will be always contracting towards what? Center. Now I am talking about solid shrinkage. Solid shrinkage is always towards what? Center. Due to solid contraction, size of the hole will be getting what? Reduced. On the casting, size of the hole will be getting what? Reduced. When size of the hole is reducing on the casting, right, diameter is reducing. On the pattern, I am going to increase the size of this hole. Size of the hole on the casting is decreasing. That's why I am increasing the size of the hole on the pattern. Please remember. Due to solid contraction, always size of the hole will be getting decreased. This point you can observe. That's why I am increasing size of the hole on the pattern. Okay? Right. 1.06. Very good. Very good. My dear friends, all are giving good answer. Right? So you can see I am going to the next problem. Right? Can I go to next problem, please? Yes, yes. Very good. Right. Next problem. Solid contraction is always toward the center. Hole size will become hota hai on the casting. That's why we are increasing the size of the hole on the pattern. This point you can observe. Okay. So answer is 1.06. It's a numerical answer type of question. Okay. Right. Then we will move to the second question. Right. Second question we will discuss, friends. It is also a good question. Please look at. Generally it is more repeatedly asking the question. But slightly I have changed this question. A 100 mm circular hole is to be produced in a casting of length 200 mm. The density of the core metal used is 0.0873 Newton per centimeter cube, and density of the molten metal used is 0.0441 Newton per centimeter cube. What is the core print area required to support the core? What is the core print area required to support the core? So we have a general formula, friends. Please remember the net force, the upward buoyancy force which is coming on the core, upward buoyancy force which is coming on the core, P will be, you can think of, friends, here Vg, please remember this point, rho m minus rho c is the formula we are going to use. Now where P is the net buoyancy force in newtons, V is the volume of the core, G is acceleration due to gravity, rho m is density of the molten liquid metal, rho c is the density of the core material. This formula I will use if the density units are in kg per centimeter cube or kg per meter cube, let us say kg per centimeter cube or kg per meter cube, where density is mass density, here mass density kg per meter cube, then I will use this formula. But here, look at, my dear friends, density units are given Newton per centimeter cube. It is not mass density, it is a weight density. Please remember, GATE examination, there is a chance of doing the mistakes here. Now here P will be equal to volume multiplied by rho m minus rho c. I am going to use this formula here, where density units are Newton per meter cube or Newton per centimeter cube. Can you please think of Newton per meter cube or Newton per centimeter cube? Okay, na? So this is weight density. It's weight density. Already in the density, G value is multiplied. Newton per centimeter cube is given. So there is no need to multiply once again with what? G value, that is acceleration due to gravity. Okay. So I will substitute these values here. Volume of the core, pi by 4 d square. Diameter is what? Centimeters. I am going to consider, friends, a circular hole, na? That is a centimeter means 10 centimeters whole square, and height is 20 centimeter. This is the volume. So it is centimeter cube. Then this is Newton per centimeter cube. So just you can difference of this densities you can consider, friends. 0.0873 minus 0.0441. So what is the value of P, you can tell. What is the buoyancy force, we can say. This is Newton per centimeter cube and this is centimeter cube, so that you are getting so many newtons. So what is the Newton, friends? Here the units you are getting here is 67.824. 67.824 newtons you are going to get. Okay, na? Now if you know this, friends, here we know that P is less than or equal to 3.5 times AC, where P is the buoyancy force, AC is the core print area in centimeter square. 3.65 is a constant. It is the green strength of this particular, now they can say core print, which is produced by mold. 3.5 is the green strength of this mold. Okay, na? So here please think of 3.5 is units are Newton per centimeter square will be there. That will take care about the units. So AC is the core print area in centimeter square. P is the net buoyancy force which is coming on the core is this much. So if you want to find out here core print area, I will consider P by 3.5. P is, we can say, 67.824 by 3.5 we are going to consider. Okay. So what is the area we are getting? Please check it. 19.37. Please check the units. Most of them are doing mistake with respect to units. This AC core print area units is in centimeter square. He is asking centimeter square, na? Please check the units. Check the units. So AC core print area will be 19 point, right? Yes, 19.38 centimeter square. 19.38 centimeter square. Very good, very good. Most of them are giving right answer, but some of them are doing mistakes with respect to units. Units balancing is very, very important. P is in newtons. AC is in core print area, centimeter square. 3.5 is a units are Newton per centimeter square. That is a green strength of the core print. Green strength of the core print units are Newton per centimeter square. So empirical formula you have to remember. ठीक है ना? Right. 19.38. Very good. Right. Please check it, friends, here. This is the question here. Sometimes we check the units. Density is given kg per meter cube. You can use this formula. Density is given in terms of weight density Newton per centimeter cube. We can use this one. Okay. So here I am considering circular hole. Sometimes in place of the circular hole, square cross section will be also there. So you can consider the volume of this particular core. Square area multiplied by length you can consider. So that volume. So if they want to change the problem, they will make it like this. Okay, na? Units balancing, core print area, right? What is the chaplet area required? What is the core print area required? Like this questions are coming. Can you please make note? Okay, right. We will move to the next question. That is question number 3. You can look at here. Question number 3 is a good question. A cylindrical casting of 25 centimeters diameter and 25 centimeter height is casted using bottom gating system. Pouring height of the metal is 30 centimeter. If the filling time is 24 seconds, then the area of the in-gate is. What is the gate area? In-gate area both will be same. Okay, na? So what type of gating system this one? It is a bottom gating system. What is the shape of the cavity? It is a cylindrical cavity. Okay, na? So please read this data. That is very, very important, my dear friends. Right. Understanding the data is very, very important. Okay, na? It is a cylindrical cavity where we are using what type of a gating system? It is a bottom gating system we are going to provide. Bottom gating system we are going to provide. And he is saying that the pouring height, liquid metal is coming at a height of 30 centimeter. At a height of 30 centimeter. And he has mentioned this is a diameter, friends, here. This is a diameter we can consider. Diameter of the cavity, it is 25, and height of this particular cavity is also 25. It's a cylindrical cavity, please remember, my dear friends. Okay, na? Now he is asking what should be the gate area, this area. The actual entry point through which liquid metal is entered into the cavity is called gate area. Actual entry point through which liquid metal is entered into the cavity is called gate area. So this is the gate area through which liquid metal is coming. This gate area we need to find out. This gate area we need to find out. What type of gating system? He has clearly mentioned it is a bottom gating system. Bottom gating system. What is the bottom gating formula to calculate filling time? Filling time will be equal to filling time will be equal to right. So 2 times AM by AG 1 by root 2G root of HT minus HM we can consider. Okay, na? So this formula, I think, hope everybody is knowing this particular formula. Okay. TF filling time is 2 times AM by AG 1 by root 2G root of HT minus root of HT minus HM. Just you can substitute in the formula, friends. Filling time is 24 seconds will be equal to 2 times mold. What is the area of this mold? Pi by 4 d square. Circular cross section pi by 4 d square. Pi by 4 diameter is 25 whole square. By area of the gate that we need to find out. Area of the gate we need to find out 1 by root 2G 981. Please think of, friends, here. All the units I am substituting in centimeter, so that G value also centimeters per second square 981. Okay, na? HT will be how much? Pouring height root of 30 minus 30 minus 25 we can consider under root. So from here please tell me what is the area of the gate. You can simplify and tell me bottom gating formula to determine area of the gate. Right. Please check it. Most of them are getting. What is the area of the gate? Please tell me. Why? 2.99, very good, very good. 2.993 centimeters square, very good. 981 centimeters per second square, G value, because remaining dimensions are in centimeter, na? 981 centimeters per second square, please remember this point. Okay. Area of the gate, 2.99, very good. 2.99 centimeters square, it will be equal to 3 centimeters square, okay. 2.99 centimeters square, correct. Please check it friends here. Bottom gating formula, filling time calculations, okay. Please remember the cavity cylindrical form. What is the area? Area of this one is pi by 4 d square. This area we have to consider, okay na? This point please remember. Right, very good, very good. Right, next we will move to the next question. Next question, please go through the next question. In a sand casting process, if the surface area is doubled for a given unit volume of the casting, the corresponding percentage change in solidification time. Corresponding percentage change in solidification time. Friends, in casting chapter, shrinkage calculations, very important. Filling time calculations. Next aspect is solidification time calculations. The next, riser design. These concepts are very, very important. These concepts are very, very important. Okay, right. Now we know that friends, according to Chavino's rule, solidification time is directly proportional to volume to surface area whole square. General friends, we are considering volume to surface area whole power n. N value is 1.5 to 2 we are going to consider. Okay, na? If nothing is mentioned for metals, we are considering n value equal 2. So volume to surface area whole square. For a unit volume is saying. So volume is 1 unit if we consider. So I can say solidification time is directly proportional to what we can say 1 by A whole square. 1 by A whole square. Now if you look at here friends, if we want to find out solidification time for two casting TS1 by TS2, if I am considering, right, if you ratio TS1 by 2 castings, first one is a TS1, second one is a TS2, solidification time. If you consider like this, it is A2 by A1 whole square. A2 by A1 whole square we can consider. This is according to Chavino's rule, Chavino's principle. But as mentioned, please observe, the surface area is doubled. Surface area is doubled. So initial area, if you are assuming A1, and final area is A2, final area is doubled. So you can say A2 will be equal to what? 2 times of A1. 2 times of A1 we can consider. Okay? Now what is happening, my dear friends here? Now A2 by A1 will be equal to 2. A2 by A1 will be equal to 2. So if you are considering this one, it is a 2 whole square, that will be equal to what? 4. That will be equal to what? 4. TS1 by TS2. Now please remember here, he is saying that corresponding percentage change in solidification time. Here, solidification time will be increasing or reducing? Solidification time will be increasing or decreasing? Please think of. Solidification time is inversely proportional to area. Inversely proportional to area. Where area is doubled, area increase hota hai. If area is increasing, solidification time kam hota hai na? Solidification time will be less, more heat transfer is there. If surface area is increasing, heat transfer losses are more, solidification time will be reducing. Percentage reduction in solidification time. Percentage reduction in solidification time we have to consider. So if area is increasing, then if you consider percentage change in solidification time, percentage change in solidification time, that is a TS, solidification time. If we consider initial solidification time is a TS1, final solidification time is a TS2 by TS1 multiplied by 100, we can consider percentage. So this is 1 minus TS2 by TS1, 1 minus TS2 by TS1 multiplied by 100. So what is given? TS1 by TS2 is 4. TS2 by TS1 means 1 by 4 I will write here. So 1 minus 1 by 4 into 100. कितना होता है? कितना percentage of percentage solidification time? Very good. So reduction in solidification time is 75%. Very good. If the area is doubled, surface area is doubled. Yes, not mention surface area, but solidification time calculations we have to consider surface area only. If area is doubled, percentage reduction in solidification time is 75% we have to consider. It is 75%. Okay, na? This is a good question. Please check it. Yes, most of them are giving, friends, right? Mechanical people are rocking. You are rocking. Very good. All are giving correct exact answer. Very good. Now please observe, friends. If no, this is one way. If we want to change this one, if the solidification time is reduced, if the solidification time is doubled, what is the percentage change in surface area? Can I calculate? So if they want to change the question in GATE examination, right? If the solidification time is reduced to 50%, solidification time is increased to 2/3 or increased to 3 times like this, then what is the percentage change in surface area? What is the percentage change in surface area? Like this also questions will be coming. Okay, na? Right. This question is also right. Very good question. Right. Please look at. Now we will move to the next question. Yes or no? Yes, if nothing is mentioned, friends, area, that's what I am saying, no? Solidification time calculations, we are using surface area only, okay? If nothing is mentioned, the area is mentioned means we have to consider surface area only, okay? Right. The next question we will think of, friends. Fifth question, please think of. This, read the question, please, first. Good, good. Yeah, two castings are differ in weight by a factor of 3.8, but they are both cubes. Two castings are what type of castings, my dear friends? Cubicle castings. Their weight difference is by 3.8. Cubes made up of same material, they are made up of same material. The lighter casting solidifies in 8.7 minutes. Light casting will solidify in 8.7 minutes. How much time will take to solidify larger casting? How much time it will take to solidify larger casting? So larger casting weight ज़्यादा है ना? Right, that's why I will consider weight W2 by W1 will be equal to 3.8. W2 by W1 will be equal to 3.8. What is this one? W2 is the weight of the larger casting. W1 is the weight of the smaller casting. They are differ by 3.8. Okay, na? Right. So it is a weight. Now both are made up of same material. Means indirectly the densities will be same, na? Read the question carefully. Made up of same material means their densities will be same. Density of the casting material will be same. So if we consider here density, let us say ρ2 and V2, and we can say G value. And you can think of, friends, here ρ1, V1, G value we can consider. So density is, both density will be same, right? Please think of G will be getting cancelled. So weight is mass into density, sorry, mass into, we can say G value, that is a weight. What is a mass? Volume into density, volume into density. Both are made up of same metal means density will be getting cancelled, G value is also getting cancelled. This is 3.8. So what we can consider here, V2 by V1 will be equal to 3.8. What type of casting? Cubicle casting. Cubicle casting, what is the volume? A2 cube. In terms of sides I am considering. A2 cube by A1 cube will be equal to 3.8. A2 cube by A1 cube equal to 3.8. We can say this value. Now if we want to find out here from this equation, A2 will be equal to how many times of A1? How many times of A1? Please tell me. 1.56. 1.56 times of A1. Is correct now? If you know this one, then problem is simple. Then how much time will take to solidify larger casting? You can say, please think of here, TS1. right? How much time will take to solidify larger casting, na? So, right. So, TS1 by TS2 will be equal to, it's a cubicle casting. General friends, cubicle casting, what is the solidification, what is the volume to surface area ratio? Volume is A cube, surface area is 6 square, it is A by 6. Right. So, A1 by 6, A2 by 6, 6 will be getting cancelled, A1 by A2 whole square, A1 by A2 whole square. Okay. So, now TS1 has given lighter casting is what solidifies in 8.7 minutes by larger size casting solidification time is TS2 is A1. In place of A2, I will write down this one, friends, here. 1.56 times of 1.56 times of A1 whole square. So, A1 will be getting cancelled. So, from here, after simplification, please tell me what is the solidification time of larger casting? What is the solidification time of larger casting? 21.17, very good. Why cubicle casting, Mr. Harshit? Mr. Harshit, he has given, na? Both are cubes, he has given, na? He has mentioned cubicle casting. In the problem, he has mentioned. I am not considering. He has mentioned in the problem. That's why I am considering Mr. Harshit. Please check it. Check the question. 21.173. Very good. It is minute. Right? It is minute. Units are minutes. 21.173. Correct? Please check it. Okay, 1718. Correct. So, numerical answer type of question, range of answer will be given, so that you are saying 21.17, 21.18, both will be correct. Okay? Right. Very good. Very good. Yes, very good. All are giving correct answer, correct. Most precise answer they are giving. I think no one has given wrong answer for this question, friends. Right? Very good. I think your preparation levels are very, very accurate. Right? Answer is more precise. Right. Can we move to the next question? Next question. Right? अरे कैसा होता है जी 4.8 कहाँ से आता जी? Check it, check it, check it here. See, small casting will take 8.7 means larger casting will take more time, na? Logically, please think of how it will be 4 point. It should be more than 8.7, na? No, no, please check it, please check it. How it will be A2 equal to? See, bada size of the cube is increasing, A is also increasing, na yaar. Okay, right, right. Please check it. Please check the question. Yeah, next question, sixth question, please check it, friends. A cylindrical casting solidifies in 8 minutes. What is the solidification time if the cylindrical diameter is doubled for the same height? This is a good question, friends. Right? It's a very interesting question. Please observe. A cylindrical casting is not riser. It's not riser. It's a casting. H equal to D. Solidified in 8 minutes. What is the solidification time? What is the solidification time if the cylindrical diameter is doubled for the same height? Height is same, but the diameter is doubled. So we are considering two conditions, my dear friends. First one, we can say H1 will be equal to D1, diameter, height equal to diameter. First case I am considering, height equal to diameter. That is the first case. So what is the second case you can consider? Diameter is doubled, D2 will be equal to 2 times of D1. Diameter is doubled, but height is same. What we can say? H2 will be equal to H1. That is also equal to what? D1. समझ में आता है ना? For the same height, H2 equal to H1. H1 equal to what? D1. But D2 equal to 2 times of D1. These are not risers, they are castings. Both are cylindrical castings only. Okay, na? So indirectly, please observe, two castings, only dimensions are changing, material will be same. Material will be same. Now we can find the ratio, friends. Please observe, solidification time of the first casting to the solidification time of second casting, volume to surface area whole square for a first casting, volume to surface area whole square for a second casting. Right. So what is the volume to surface area of the first cylindrical casting? That is pi by 4 d1 square multiplied by height h1, 2 times pi by 4 d1 square plus pi d h1, d1 h1 whole square, this one. It is a cylindrical casting, please observe. Cylindrical casting, we are considering total surface area. I am going to consider. Total surface area we are going to consider. This is the height, this is the diameter. समझ में आता है ना? What is the, please think of here, this is the height, this is the diameter. So volume is pi by 4 d square into height. Bottom and top, two circular cross section, 2 times pi by 4 d1 d square, and lateral surface area pi dh. So that is the first case. And second case, if you consider, second case if I am considering, right, what is happening here? This we can consider here. Yeah. So this one is pi by 4 d2 square h2 by 2 times of pi by 4 d2 square plus pi d2 h2 can consider whole square. Okay. Now you can consider, if you substitute h1 equal to d1, na? In place of h1 if you substitute d1, if you simplify, you are getting d1 by 6 whole square. d1 by 6 whole square. Substitute in place of h1 d1, so that if you simplify, you are getting d1 by 6 whole square. Then second case, if you are getting here, in place of d2, I am finding substituting 2 times of d1. In place of what we can say h2 equal to h1, and that will be also equal to d1. If I am substituting, you are getting this will be equal to d by 4 whole square. Please substitute the condition. In the first case, substitute h1 equal to d1. Second case, d2 equal to 2 times of d1. Okay? Right. This one. Now if you simplify this one, 4 will be getting cancelled. क्या होता है? Initial, this one is what? First one is 8 as mentioned minutes, na? Right. So TS2 will be equal to, so D will be getting cancelled, 1 by 6 into 4 by 1. So 4 by 6 whole square. Don't forget this whole square, friends, because in hurry sometimes there is a chance of missing this square. If you miss this square, then 2 marks will be gone and followed by negative marking also. ठीक है ना? Right. So from here, what is the TS2? Please think of. What is the TS2? Please think of. Yes, 18 minutes. Very, very good. You are giving very, very fast. Yeah, the answers you are giving is very, very fast. 18 minutes. Please check it here. Okay. So that the simplification is yes, very, very good, right? All of you are giving most precise answer without any deviation. 18 minutes is the correct answer. 18 minutes is the correct answer. Yes, excellent. Check the units, because minutes, na? This also minutes, right? So this is a simple question, na? Right. Next question we will discuss, friends, here. Right. We'll slightly move to the riser design concept. Riser design. Calculate the dimensions of cylindrical blind top riser with h equal to d. Cylindrical blind top riser with h equal to d to produce a casting of dimension 25, 12.5 and 5 centimeter cube. Use Chauvinot's principle. Friends, we have discussed there are 4 methods of riser design, right? But he has not mentioned that 4 methods. He has mentioned Chauvinot's principle. So what is the Chauvinot's principle? Will say solidification time is actually solidification time. We can think of, friends, here. According to Chauvinot's principle, solidification time is directly proportional to volume to surface area whole square. Please listen, friends. This is a multiple select question, this one. MSQ. How it will be MSQ, we will discuss, friends. Right. So how this Chauvinot's principle will be used in riser design means, we have discussed, friends, solidification time of a riser should be greater than or equal to solidification time of what? Casting. Strictly speaking, solidification time of the riser will be more than what? Casting. What is the worst condition? Worst condition is at least it will be equal. Solidification time of the riser equal to solidification time of the casting. Okay. So, but see, casting should not be greater than what? Riser. Because we have discussed here, this is a cavity over which we are going to provide a riser, let us say. Now, if I fill the metal into this particular cavity and riser also, if shrinkage will be taking place in the cavity, to compensate the shrinkage, metal has to come from where? Riser. That's why solidification time of the riser should be greater than the solidification time of the casting. Worst condition is at least equal. It will be at least equal, we can say. Okay. Now, this condition I am going to use here. Okay. Alright. So, solidification time of the riser means volume to surface area whole square for riser. It should be greater than volume to surface area whole square for a casting. Whole square for a casting. Now, please observe here regarding volume to surface area of the riser. Please you can read the question carefully. It is what type of riser? Cylindrical blind top riser, friends. It is a blind riser or it is an open riser. Conditions will not change. Open riser means the top surface of the riser is open to outside. It is called what? Open riser. If the top surface of the riser is also covered by molding sand, it is called blind riser. Blind riser, we can think of, friends. We can have a top riser will be there, side riser is there. Open riser also we can have a top riser and side riser. Conditions will not change. Is mentioned blind riser means it is covered by molding sand. Top surface it is covered by molding sand. Take it now. This point you can say. And he has mentioned H equal to D. Please remember. General, what is the optimum condition in case of top riser? H equal to D by 2. But he has mentioned H equal to D. Means it is not a optimum top riser. It's not a optimum top riser. Optimum top riser means what is the condition we can consider? H equal to D by 2. H equal to D by 2. So he is not giving H equal to D by 2 optimum top riser. We can consider any condition here. He has given H equal to D, that we are going to substitute. It is what type of riser? Top riser. So here if we consider pi by 4 D square multiplied by height by surface area of the riser. Please remember, at the bottom where you are positioning the riser, bottom surface, there is no heat transfer. It's the top riser. So this is pi by 4 D square plus pi dh. This is the surface area in case of top riser. It will be greater than or equal to volume to surface area of the casting 25 12.5 into 5 centimeter by surface area is 2 times of 25 into 12.5 plus 12.5 into 5 plus 5 into 25. This is the surface area whole square. And in this case you can substitute, friends, H equal to D. If you substitute, you are getting, I think, D by 5. You are getting D by 5. Yes, D by 5. Very good. D by 5 will be greater than or equal to, how much this simplification you are getting? 7.8125. 7.8125 centimeter. So there are two possibilities, friends, here. First one is D equal to, first one is, let us say D is greater than, first we can make it, friends, greater than 7.8125 centimeter. This is also correct. D equal to 7.8125 centimeter. This is also correct. So in the answers, friends, 7.8125 or greater than 7.85125, also any please option is there, that is also correct. Let us say 8 point something is there, that is also correct. Anything less than 7.8125, it is not correct. Okay, na? So options I have not given, but here there is a possibility that here 7.8125 is correct. Greater than 7.8125, any answer is there, that is also correct. That is also correct. It is a multiple select question. Okay, na? See, blind riser or open riser, there is no change, my dear friends. That's why I have explained, na? Blind riser क्या होता है? Top surface is all covered by molding sand, but heat transfer होता है ना? Heat transfer through the molding sand by conduction will be there, right? Heat transfer losses will be there. So there is no difference in, if you consider top riser, blind riser or open riser, there is no difference. Sometimes to confuse you, this type of statements are coming in the exam. That's why I have added. Open riser or blind riser, whatever they will give, you forget about. There is no issue for that. Whether it is a top riser or side riser, you have to consider that one. Okay, na? If the top surface of the riser is open to outside, it is called open riser. The top surface of the riser is also covered by molding sand, it is called blind riser. But in blind riser also heat transfer hota hai. Top riser is there, side riser is also there in case of blind case. Okay, right. So the answer is 2, friends, here. 7.8125 or greater than 7.8125, both will be correct. Okay, right. Yes, D by 5, because in this equation you have to substitute what? H equal to D na. If you substitute H equal to D in this particular equation, you will get D by 5. If you simplify this one, you will get 7.8125. Okay? Right. We'll move to the next question, friends. Right. A cylindrical top riser H equal to D by 2 is used to feed a casting of 25, 15 and 5 centimeters cube. If freezing ratio is 1.5, then radius of the riser is, what is the radius of the riser is asking. Please observe. The concept is coming from where? Keynes method. Keynes method, we are using this concept now, freezing ratio concept. Right, listen, Keynes method, if here is giving, it will be difficult to calculate. That's why he has modified that Keynes method in the form of what? Freezing ratio. Okay, so what is the freezing ratio, my dear friends, here? Freezing ratio will be equal to surface area to the volume of the casting to the surface area to the volume of what? Riser. Same I will write, because this is a ratio, no? Volume to surface area of the riser to the volume to surface area of what? Casting. Both will be correct, na? Both will be correct. Sometimes right, questions are giving like this also, friends. Surface area to the volume of the casting, surface area to the volume of the riser ratio. This is a cooling characteristics of the casting to the riser. It is a ratio between cooling characteristics of the casting to the riser. Or you can say volume to surface area of the riser, volume to surface area of the casting. Okay, right. Now you can think of here, friends, the casting dimensions are given. Next, he has mentioned cylindrical top riser. So here he has not mentioned blind riser or open riser. So we are not bothering about. What type of riser? Top riser. What is the condition? H equal to D by 2. Optimum condition of the riser is given. It is a top riser. Okay. Now if you consider here, freezing ratio is how much, friends, here? 1.5. Okay. So I will make it one more step here. What is the volume to surface area of the riser? Pi by 4 D square multiplied by height. What is the surface area? It is a top riser, pi by 4 D square plus pi dh. I am going to consider this one. And what is the volume to surface area of the casting? 25, 15 into 5 by 2 times of 25 into 15 plus 15 into 5 plus 5 into 25. Surface area of the slab, whole square. It is whole square. Sorry, whole square is not there, no, I am sorry. Because it is a freezing ratio, there is no whole square here. Okay? Right. Now, if you simplify this one, friends, if you substituting here, freezing ratio is how much he has given? 1.5. Freezing ratio is given 1.5. Okay. This will be equal to, right, in this particular numerator, I am going to substitute what? H equal to D by 2, so that you are getting D by 6. Please check it, you are getting D by 6. Then what is this value you are getting here? This value you are getting is how much? Please check it. .63, it is correct, I think. Please check it. 1.63, it is, please check it here. Is asking radius, friends. We will find out radius now. Then radius of the riser is asking. 1.5 is a freezing ratio. This is D by 6, 1.63. Yes, very good. Now you can get from here, diameter you are getting here is right 14.67 centimeter, and is asking about radius. Radius will be 7.33, correct? 7.33 centimeter. From the formula you are getting diameter, that you can make it R equal to D by 2. Okay. So Keynes method he has modified using the concept of freezing ratio. We need to calculate the dimensions of what? Riser. Please check it, answers is correct. Yes, very good. Pooja Meena, yes, very good. Everybody is giving correct answer. Friends, yes, in hurry, don't put D value. Check the placing of units. He is asking what? Radius, not diameter. But in the formula we are using no diameter. You can use formula in terms of radius also. After getting diameter, you can find substitute in radius, because he is asking radius of the cylindrical riser. Okay, right? So after solving this one, just a final substitution of answers also very, very important. Okay, final point is very, very important. So D value, because by getting the answer you will substitute this one, but it's not asking D, it's asking radius. Okay, right, very good. All of you are giving the correct exact answer. Very, very good. Right. We'll move to the next question. Another interesting question. This is an interesting question. Can you please look at modulus method? We will discuss. Calculate the dimensions of cylindrical top riser H equal to D to produce a spherical casting. What is the shape of the casting? Shape of the casting is a spherical form of the casting. Okay, na? So if we consider spherical form of the casting, over this we are going to provide what? Riser. So riser is in what? Cylindrical form. Cylindrical top riser is saying, he has given top riser once again H equal to D condition, means it is not a optimum top riser. H equal to D by 2 means it is a optimum top riser. It is not a optimum top riser, you can use any condition. Okay, right. Yes. So we need to find out, friends, here what is the right, what is asking here? Use modulus method, no? Modulus method is asked. Oh. Actually, there is no, please think of here, gap between these ones. That's why I want to because there is a possibility of flow of the metal, na? Right. Now you can see modulus method. What the modulus method will say? Modulus will be equal to, general friends, modulus will be equal to volume to surface area. It may be for casting or it may be for riser. So modulus. So what is the formula here? Modulus of the riser equal to 1.2 times modulus of the casting. This formula you have to remember. So riser modulus will be 20% greater than what? Casting. It should be 1.2 times of what? Casting. Okay, right. So what is modulus of the riser? Volume to surface area of the riser will be equal to 1.2 times volume to surface area of the casting. Volume to surface area of the riser, same story, pi by 4 d square multiplied by height. Surface area is what? It is a top riser. So not 2 times, only pi by 4 d square plus pi dh we will consider. There is no square here. 1.2 times of volume to surface area of the casting. What is the shape of the casting? Spherical shape. Spherical shape, what is the volume to surface area, my dear friends? Spherical shape, volume of the sphere is 4 by 3 pi r cube. What is surface area? 4 pi r square. क्या होता है? R by 3 or D by 6. R by 3 or D by 6 we can consider. Yes, given diameter, no? That's why I am putting D by 6 D by 6 we can consider. Now here, this we are getting, friends, from here, this value, if you substitute H equal to D, here how much you are getting? I think D by 5. You are getting is D by 5. So D by 5 will be equal to 1.2 times of D by 6. 1.2 times of D by 6. What is the D value? 200 by 6. 200 by 6. So from here, if you simplify, we are getting D value will be equal to, I think, 200 mm, correct? 200, oh sorry, I'm sorry. D value equal to 200 mm. Exactly. D value equal to 200 mm. Please check it. Arey yaar, how this riser looks physically means it is a cavity, spherical cavity. Riser is a cylindrical riser, na? I will position this riser. Your cavity is in spherical form. Riser is in cylindrical form only. Riser is in cylindrical form only, na? D equal to 200 mm. ठीक है? 27.77 कैसा आता जी? Mr. Sheikh, please check it. Please check the answer. D by 5 equal to 1.2 times or 200 by 6. D equal to 200 mm, exactly correct. Modulus method. Sometimes in the exam they are mentioning which method we have to use. So modulus method they have mentioned means we have to use that method only. Okay, right. Yeah, this one also please check it. A cylindrical side riser H equal to D is a side riser is used to produce a slab casting of dimensions. Total solidification time of the casting is 1.5 minutes. Total solidification time of the riser is 3 minutes. Diameter of the riser is how much? So the term total solidification time is having some significance. So you can, I think, please if you look at here, generally in riser design, friends, we are considering here. Right. So if you consider temperature versus time graph, pouring temperature, freezing temperature, right? This one we can consider. And this is one, right? Temperature versus time graph if we consider here. Actually, so this is from A, B, C and D. So liquid metal will start solidification from here to here. This time is called B to C, it is called local solidification time. Local solidification time. local solidification time, right? So liquid metal will start solidification at point B and it will ends at point C. It is a local solidification time. But if we consider from here to here, friends, starting point from here to here, this time we can consider when the liquid metal will be filled into this cavity. After filling hone ke baad, if you start measuring the time from A and it will be getting solidified at point C, this time is called total solidification time. Total solidification time. Total solidification time. Okay, na? So this is the time we have to consider. Strictly speaking, we have to consider the local solidification time only, because up to point B, metal is in liquid form only. So liquid metal will start solidification at point B, it will ends at point C. This time is called the local solidification time. So strictly speaking, solidification time means this one. But practically it is difficult to measure at which point the liquid metal will start solidification, at which time. We require sophisticated system, thermocouples may be required, right? So that's why we are considering, friends, after filling up the metal into the cavity, filling hone ke baad, immediately I will start stopwatch. After filling hone ke baad, at pouring temperature, if you are filling the metal into this one, then if you are start measuring the time, and at the end where the liquid is converted into solid form, the total time we are considering the total solidification time. So both the cases he is asking total solidification time only, so there is no need to worry. So total solidification time, what is the meaning, you may be getting doubt, that's why I am giving this one. Okay? Now we can consider simply solidification time of which one? Riser to what? A slab casting. So solidification time of the casting to the solidification time of the riser. Solidification time of the casting to the solidification time of the riser. So volume to surface area whole square for a casting, volume to surface area whole square for a riser. So this is solidification time, but he is asking with respect to casting and what? Riser. Casting and riser. Okay, this one. Now you can think of, friends, here solidification time of the casting is how much? Solidification time of the riser is 3 minutes. Casting is 1.5. It will be 3 minutes. Volume to surface area of the casting, right, is 10, 5 into 2 by 2 times of 10 into 5 plus 5 into 2 plus 2 into 10. I am using Chevinow's principle, that's why it is whole square. Volume to surface area of the riser. What type of riser? Cylindrical side riser with H equal to D. Volume to surface area is simply D by 6, na? D by 6 I am putting, friends, here. D by 6 whole square. If you want, you can check it also. Volume is a side riser. Volume to surface area means pi by 4 D square multiplied by height. 2 times of pi by 4 D square plus pi dH. If you substitute H equal to D, you are getting a D by 6. 2 times pi by 4 D square, it is a side riser. So from here, what is the value of D? What is the value of D, please tell me? 5.3 centimeter, very good. 5.3 centimeter. Heater band kariya. D equal to how much now? 5.3, not 2.65, it is 5.3. Simplification is required. 5.3 centimeters. Please check it. One more time, some of them are giving small difference in answer. Please check it. 5.3 centimeters. Answer is 5.3 centimeter. Sorry, right? Correct? Yeah, very good, very good. Yes, yes, very good. 5.3. Live कितना हो गया? Very good. Yes. we'll move to the next question, friends. Next question. I think 5.3 is the correct answer. Yeah. This theory question, friends. Sometimes multiple select questions, MCQ, theory questions also coming now. We will cover that also. Which of the following statements is or false? Please remember. False statements. It is MSQ. Is or as given is MSQ. How many are false statements? Please observe. Centrifugal casting is used to produce a hollow objects without using a core. Correct na? Without using the core to produce a hollow casting, we will use centrifugal casting. That's the correct statement. It's the correct statement. Okay. He is asking false statement. That's why I am not considering the first one. Second one. Ferrous metals can be cast by die casting. No, it's the wrong answer. It may be cold chamber or hot chamber die casting. Both can be meant for non-ferrous metals only. Low melting material. Because if you are going for ferrous materials, its melting temperature ज़्यादा है. So if you want to produce a ferrous material, die should be made up of still high melting point material like graphite. We have to consider. Okay, right? Ceramic or graphite. That's why we are not using for ferrous materials. Die casting is not meant for ferrous materials. So B is a false statement. That's why we have to consider here B. Okay, B is correct. We have to consider it's a false statement. Investment casting is not used for complex shape. It is used for complex shape, na? Right. So C is also we have to consider. Next, in plaster molding, plaster of Paris can be used as a molding material. Mold is prepared by plaster of Paris, POP. Right. Plaster molding, plaster of Paris, POP can be considered as a molding material. This is a correct statement. So what are the statement friends here? B and C will be the correct. What are the false statements? B and C. A and D are correct. A and D are correct. B and C are false statements. ठीक है ना? Very good. B and C are false statements. He is asking false statement, please. Okay. Read the questions carefully. If it is a multiple select questions, we have to be more cautious and you have to check it properly. Okay. If it's a multiple choice question, we can easily write a select. But multiple select questions means you have to think properly. Okay? Right. This question is clear? This question is clear? Right? Right. Now this is regarding applications, friends. Applications. Generally, this type of questions are very much common in manufacturing. In manufacturing, definitely one question we are expecting with respect to this one. Match the following type of questions. Okay, right. List one process is given, list one product or metals are given. So which one we have to make a match the following, right? This one. So die casting, general die casting we can produce aluminum alloy piston. Na? Aluminum alloy piston can be produced. So A4, gravity type of die casting we are using, friends. Okay. Please, sir, he has not mentioned which one how to consider. See, generally nothing is mentioned permanent molding technique. Die casting means you can consider gravity die casting. Okay, right. A4. Extrusion. Extrusion can be used to produce aluminum objects made of doors, windows and doors, panels, right? That is channels. Panels can be produced by extrusion. That is B3. Blow molding. Blow molding is used to produce hollow objects. Na? What we can say? Plastic water bottles can be produced by blow molding. C2. What is the D? Powder metallurgy. Where powder metallurgy can be used to produce what? Tungsten carbide tools. Tungsten carbide tools can be produced by powder metallurgy technique. Because tungsten carbide's oxide formation is there. That's why they are not produced by casting technique. If you start heating, they will be converted into oxide form. They are going to produce by using the technique called what? Powder metallurgy technique. That is a D1. So this is the option, friends, here. A4, B3, C2, D1. Good. 4, 3, 2, 1. Very good. Yes. Yeah. Then we will move to the next topic, friends. That is welding. Right. We will start with the welding. First we will take up theory question, then we will move to the next one. Okay. Now please observe, regarding fusion welding technique, which of the following statements is or correct? It's an MSK question. Which of the following statements are correct? Can you please think of, in a fusion welding technique, we are melting this base material and we are melting the filler material. This base material and filler material is melted and it will be allowed to solidify. It is a fusion joint. This is a base material. It is a weld joint or fusion zone we will consider. Where fusion, see, the bond formation will be taking place between the filler metal and base metal by the action of what? Fusion. Bonding will be taking place. Filler metal is getting solidified between the two workpieces to produce a fusion joint. Okay. Now please observe what type of stress will be developed is asking. Can you please look at here? Now regarding the stresses, please observe. If you cool after filling up this metal between the two base materials, this liquid metal is allowed to solidify. Once it is getting solidified, can I expect solid contraction will be there now? If you cool the metal from freezing to ambient temperature, what happen? Solid contraction will be there. So due to solid contraction, what happened? Please look at, the filler metal is moving toward the center due to solid contraction. Filler metal is moving towards what? Center due to what? Solid contraction. Solid contraction is taking place in the filler metal. Due to solid contraction, the metal is, the filler metal which is getting solidified in the joint is moving towards what? Center. Means it is a type of force which is coming on the metal is, contraction means it is a compressive. It is moving toward the center. Contraction means it is a compressive. Once the force applied will be contraction, the stress developed in the material, please observe. If I am applying the force, internal resistance developed to overcome the external force. If you apply the external force, internal resistance developed by the metal is called what? Stress. So what stress will be developed inside here? The stress developed will be tensile. In the joint, the stress developed will be tensile. Contracting force is coming toward the center, solid contraction. So to overcome this one, the stress developed in the material is what? Tensile. Next, during the process of fusion bonding, please observe, between the filler material and base metal, there is a possibility of some bonding will be there. Between the filler metal and base metal, there is a chance of some bonding will be there. If the filler metal is contracting toward the center, the base metal will provide some resistance in which direction? Opposite direction. If the filler metal is contracting toward the center, base metal will provide some resistance in opposite direction. If the base metal is providing in opposite direction, this direction the force is applied, it will be tensile. If the tensile force will be applied by this base material against this contraction of the filler material, what type of stress will be developed in this particular material? It is compression. It is compression. So the stress developed will be compressive in nature in the base material. Stress developed in this particular filler metal will be tensile. It will be tensile. Now the question, please closely observe friends here. What is given? Compressive stresses are generated in the parent material. It is correct. First statement is correct. Tensile stresses are generated in the weld. It is also correct. Tensile stresses will be generated inside the weld. These two statements are correct. Next, tensile stresses are generated in the parent metal. This is wrong. Right, this one. So what is the option friends here? A and B both will be correct. A and B both will be correct. Okay, right. This point please closely observe. A and B both statements are correct. It is a MSQ question. Yeah. Now this we will move to the next numerical question friends here. Numerical type of question. Voltage length characteristics, VI characteristics, voltage length characteristics with respect to this one numerical questions will be coming. Okay, right. This we have discussed number of questions. Can please look at. A linear voltage arc length characteristics, you can think of VA will be equal to 20 plus 40 LA, where arc length is in centimeters he has given. Generally, if nothing is mentioned, arc length will be in mm. VA is arc voltage in volts. But specifically as mentioned, arc length will be in centimeter. You can put in centimeter. Okay. VI characteristics is linear. Yes, clearly mentioned linear and open circuit voltage of 80 volts. Short circuit current of how much? Short circuit current of 400 amperes we can say. And he is mentioning friends please, determine the voltage and current for obtaining maximum arc power. Maximum power. Arc power or maximum power you can say. And what is the optimum arc length? So here's linear power source characteristics, maximum power condition is there. So we can use our shortcut method now. What is our shortcut method? Vt equal to V0 by 2, that is be 80 by 2, it will be equal to 40 volts. IT will be equal to Is by 2, it is 400 by 2, it will be equal to 200 amps. So you can use this method, this shortcut, if linear power source characteristics is there, maximum power condition is there, we can use this one. Okay, na? Now he is asking friends, determine the voltage and current for obtaining maximum arc power. Vt equal to 40 volts, It equal to 200 amperes. That is correct. He is not asking the power. If they ask the power, maximum power means 40 into 200, you can calculate, multiply, so that you will get the power also. Okay, na? So power, if they ask 40 into 200, if you multiply, then you will get what? Power. And next one friends is asking what optimum arc length. So Va equal to Vt. It is a linear power source characteristics, na? Linear power source characteristics. What is a stable arc generation condition? Stable arc generation condition for linear power source is Va equal to Vt. So we know that Vt equal to Va, that will be equal to 20 plus 40 La will be equal to Vt. Vt will be equal to what? 40. So 40 La will be equal to 20. La will be equal to 20 by 40. 0.5 centimeter, or we can say arc length. Yes, not given friends anything, so I can substitute in mm, that is 5 mm we will consider. Units will be given, yes, not given the problem. So 0.5 centimeter or 5 mm we will consider. 0.5 centimeter or 5 mm, correct. Adit Kumar, how you got 8, please check it. 8 kilowatt you are saying, okay, okay, correct. 8 kilowatt, okay. Yeah, very good. 8 kilowatt power. Power he has not asked in this problem, okay. Okay, okay. Arc length, no? Right. Centimeters you can substitute here, given, no? Arc length in centimeters. So optimum arc length 0.5 centimeters, correct. 0.5 centimeter, correct, correct. 0.5 centimeter, yes, given the problem. Correct. It's a good question. So whenever the possibility of this shortcut what we have discussed, if you are using that, we can save lot of time. Otherwise, without using shortcut also we can find out, right, power you can substitute in terms of arc length, differentiate the power with respect to arc length and equate it to 0, you will get what is the optimum arc length. That can be possible. Okay, now? Right. Yes, yes, very good. Right. Then we will move to the next question. A DC welding machine with a linear power source characteristics having no load voltage of 80 volts and short circuit current of 1000 amperes. No load voltage means open circuit voltage. Open circuit voltage. During welding, the current changes from 400 amperes to 500 amperes when the arc length changes from 3 mm to 5 mm. The linear voltage arc length characteristics of the welding arc. So linear arc length voltage characteristic means Va equal to A plus B La. So here we need to find out what A and B constants we have to find out. Linear arc length voltage characteristics we have to consider. And my dear friends, you can observe here, I think, right, if he has mentioned Vi characteristics is linear, linear voltage arc length characteristics are given. You can think of here, initially at V1, the current is what? I1. If you are increasing the voltage, friends, for example, if you are increasing the voltage by increasing arc length, if voltage is increasing, corresponding current will be getting what? Reduced. Corresponding current will be getting what? Reduced. They will be inversely proportional. Okay, na? So initial, let us say V1 at arc length L1, V1 is there, corresponding current is I1. If I am increasing the arc length, voltage is increasing V2, but the corresponding current will be getting what? Reduced. I can say arc length LA1 will be how much? 3 mm. The corresponding current IT1 will be equal to what? 500 amps. And LA2 will be equal to 5 mm. The corresponding current I2 will be equal to what we can say? 400 amperes of current we are going to consider. IT1 is 500, IT2 equal to 400. Arc length is changing from 3 mm to 5 mm. Okay, na? Right, now we have to use these two conditions, friends. Here. This is very important because VI characteristics is linear, he has mentioned. Okay, now we can given, friends, open circuit voltage he has given what? 80 and short circuit current also. So we know that VT equal to V0 minus IT by IS multiplied by V0. Just a simplification only. VT1 will be equal to V0 80 minus IT1 500 by 1000 multiplied by 80, it will be equal to 40 volts. VT2 will be equal to 80 minus 400 by 1000 multiplied by 80. So this is, I think you are getting, friends, how much it is? 48 na? 32 means 48 volts we are getting here. So two equations, friends, two unknowns are there. Stable arc generation condition is Vt equal to Va. Vt equal to Va. Arc length characteristics he has mentioned linear. I will use linear arc length characteristics. Va1 will be equal to 40 A plus B. Arc length is 3 mm. Equation number 1. 48 will be equal to A plus B into 5. It is equation number 2. So from here you can solve this one, friends. A equal to how much? B equal to how much? Please tell me. How much A and B, please tell me. Very good. I think some of them are giving answer also. 12 and 4, correct. A equal to 4, B equal to 12. So what is the equation, friends, here? Va equal to 4 plus 12 LA, where arc length in mm. So arc length and arc voltage is a linear relationship. This equation we have to use. This equation. Okay, na? Sometimes arc length voltage characteristics are given, then we will find open circuit voltage, short circuit current. Right? Sometimes Vt and It. Sometimes we can say relationship we have to find. Okay, please stop. Hence here if you consider, if voltage will be less, current is more. If voltage is increasing, current will be getting reduced, because the relationship between voltage and current is what? Linear. Relationship between voltage and current is what? Linear. TK? Correct. Can we move to the second one? Yes, very good. A equal to 28, kaisa tha ji? VT1, VT2. VT1 is 40, VT2 is 48. Can you please check it? Check it. I have explained initially, you are not listening to me. Arc length 3 mm, corresponding current is 500. Arc length is increasing, voltage is increasing, current is reducing. Mr. Verick, I think please check it. VT1, VT2 थोड़ा difference होता है ना? See, if the current is decreasing, voltage has to increase na? See, IT2 400, but we can say VT2 is 48. Right, no, Mr. Velik, check this one here. I have mentioned na. See, arc length is changing from 3 mm to 5 mm, but the current changes from 400 to 500 is the range. But see that V1 voltage is less, current is more. voltage is increasing, current कम होता है. Please observe, it is a linear relationship. Please see the figure. See the figure. See the figure. Yeah, very good. Equation is correct. Yeah. Next question, friends. It's a very, very interesting question. Very, very interesting question. Please look at this one. Good question, please observe. Two mild steel plates of 1 meter length are butt welded using a power source of 40 volts and 450 amperes. Current, voltage and current. While welding, 6 electrodes of diameter 4 mm and length of 450 mm are used. If melting factor, process efficiency, heat required to melt the electrodes are 30%, 85%, 10 joules per mm cube respectively, then the welding speed is. Please listen, my dear friends. 1 minute, can you please look at me? Then you can write. Okay, na? What basic concept we will discuss. So he has mentioned, please observe, two work pieces are there. They are going to join by butt welding technique. So if nothing is mentioned, I will consider square butt, let us say this one. This one. And he has given, friends, 1 meter, this one. 1 meter is the length I am going to consider here. This length of this workpiece will be 1 meter. 1 meter here. Okay? And I am going to produce a, please think of here, this is a, the joint which is going to be produced by adding the filler material. So this filler material I am going to add by melting what? Electrodes. How many electrodes? 6 electrodes I am using. 6 electrodes of 4 mm diameter, length 450. So it is in cylindrical form, diameter and length is given. So can I find volume? Volume multiplied by 6 electrodes. By melting, we are filling the gap between the two workpieces. So volume of this weld joint is electrodes volume. How much electrodes volume we have to consider? This is assumption. What is assumption we are considering? In the joint, please remember, my dear friends, first listen, then you can calculate. First listen the concept. Here I am assuming, here the assumption is the joint is produced by melting the filler material only, by adding the filler material only. In the joint, we are not assuming that base metal is melted. But what is happening practically? In this joint, some amount of filler metal is there, some amount of base metal will be also there. Some amount of filler metal is there, some amount of base metal will be also there. But how much portion of base metal, how much portion of the filler metal, we don't know. Because it's a fusion welding technique. We are generating the heat, so base metal is melted, filler metal is also melted, we are producing the joint. So here we are making assumption that total joint is produced by adding the filler material only. So here in this joint only filler metal is there. And we are assuming that there is no base metal is melted. That is the assumption. So what is the volume of the joint here? Volume of joint will be equal to 6 multiplied by number of electrodes, pi by 4 d square. Diameter of the electrode is 450 mm whole square multiplied by 4 mm we will consider. So this is a volume of the joint. It is a volume of the joint. Now I need to find out area of the joint, friends. Area of the joint, if you want to consider, volume by this meter length I can consider now. Volume by linear dimension, length of this particular one is given 1 meter. So volume by length, if you consider, we are getting what? Area. So area of the joint here will be equal to, volume of the joint. So volume of the joint, that is 6 into pi by 4 d square 450 whole square multiplied by 4 by length is I can say 1000 mm, 1 meter, na? 1000 mm. So if you use this one, friends, we will get the area here. How much area you are getting? Diameter is, diameter is 4, na? 1 minute please. I am sorry. Yeah, उल्टा हो गया. Right. So what is the value, friends, you are getting here? 33.912, correct? 33.912 mm square is the area. It is correct, please check it. Yeah, 33.93, that is the area. Now we know that, friends, melting efficiency will be equal to heat required to melt by heat supplied. Heat required to melt, heat required to melt. Heat supplied is V into I by area welding speed multiplied by heat transfer efficiency. Multiplied by heat transfer efficiency. Area multiplied by welding speed multiplied by heat transfer efficiency. Melting factor, heat transfer efficiency factor, sometimes efficiency also given by factor. So from here, if you look at here, what is the melting efficiency as given? 0.3. Heat required to melt is 10 joules per mm cube. Voltage 40. Current is how much? 450 amperes of current. By area of this particular weld bead is given 33.912 multiplied by welding speed. Heat transfer efficiency is 0.85. So from here, please tell me, what is the welding speed? What is the welding speed? Here we need to calculate what is the welding speed. Welding speed we need to calculate. So what is the welding speed? Please tell me. 13.53 mm per second. Deepu. Now I am writing, friends. 13.35 mm per second. Correct? Please check it. 13.35 or 53? 53. Okay, okay. 53. 13.53 mm per second, correct. It's a good question, right? I am repeating, friends, here in the joint, by melting the filler metal only, joint is producing. In the joint volume, total volume of the metal is coming by melting the filler material only. Means there is no contribution from the base material. There is no contribution from the base metal. If we want to make a little bit more complicated, let us say 60% in the joint, 60% of metal is from the filler material, 40% of metal will be there from the base material. If that is the case, right? So how much will be the contribution from this filler metal? Means 0.6 we have to multiply it. No, like this we can think of. But here, if nothing is mentioned, total volume of the joint is coming by melting the filler material, that is electrode only. How did you calculate the volume? That is, joint is produced by melting the electrode, na? By melting the electrode. If you are using 6 electrodes I am melting, I will produce the volume of the joint. So this joint metal is coming from where? By melting the electrode material. Consumable electrode material, diameter is given, height is given, 6 electrodes are given. So I am multiplying with this one. ठीक है ना? So this volume divided by length. Length of this particular workpiece is given now. Volume divided by length will give what? Area. Cross section of this weld bead. Cross section. So this is a T, this is a B, right? Area we can calculate na? Area. Yeah, practically base metal is also melt. But without that assumption we can't solve the problem. Without that assumption we can't solve the problem. Right? Practically base metal will also melt. Yeah, next, this is a theory question, friends. I have given one theory question. Please look at. Which of the following statements are true? In GTA process, what is mean by GTA? Gas tungsten arc welding means TIG welding. Gas tungsten arc welding process, consumable electrode is used. Array tungsten by tungsten. Tungsten means non-consumable electrode na? Non-consumable electrode. Galat statement hai. In GMA, gas metal arc welding means MIG welding. MIG welding, both AC and DC power supply can be used. Yes, we can use direct current state polarity, reverse polarity, AC can be used depending on the application. It is a statement. Submerged arc welding is not used for mass production. It is a correct statement. Generally, submerged arc welding, high current will be there. High deposition rate will be there. High welding speed is there. So we can join high thickness materials at a faster rate by using submerged arc welding. It's a correct statement. But here he has mentioned it is not used. Not used. That's why it is a wrong statement. Plasma arc welding process depth of penetration is very high. It's correct. Because heat generation is 20,000 degrees centigrade and it is focusing at a small area. Heat constant, heat flux is very high in plasma arc welding. So depth of penetration is very high. That statement is correct. So which are correct, friends, here? B and D statements are correct. B and D statements are correct. Okay, na? Please check it. Sometimes theory questions will be given like this to confuse you. It's MSQ question. Okay. All right. Move to the next question. Yeah. We'll discuss numerical question with respect to spot welding, resistance welding. VI characteristics, melting efficiency in arc welding, melting efficiency in resistance welding. These three areas are important with respect to numericals. A spot welding of two steel sheets, each of 1 mm thickness, is performed using 20,000 amperes of welding current for 0.15 seconds. Assuming interface resistance is 200 micro, heat required to melt the steel metal is 10 joules per mm cube and thermal efficiency is 60%. Volume of the weld nugget is how much? What is the volume of the weld nugget is asking. Okay, na? So please first we will find out, friends, here heat supplied. Can I calculate heat supplied or heat generated will be equal to I square RT. I square RT. That is 20,000 whole square. Resistance is 200 micro, 200 into 10 power minus 6 into time, seconds 0.15. So how much you are getting this value? This value I square RT. Heat supplied or heat generated will be equal to, how much you are getting this one? 12,000 joules. 12,000 joules of heat supplied, heat generated or heat supplied on the workpiece material. We know that, friends, melting efficiency will be equal to heat required to melt by heat supplied. So from here, heat required to melt will be equal to melting efficiency is how much? Thermal efficiency or melting efficiency, both will be same. 0.6 multiplied by heat supplied is 12,000. So how much is the heat required to melt here? Heat required to melt is how much? $7,200 joules will be the heat required to melt. So many joules, but he has given heat required to melt per unit volume is 10 joules per mm cube. So if you want to find out volume of the nugget, volume of the nugget equal to heat required to melt by heat required to melt per unit volume. Heat required to melt by heat required to melt per unit volume. What is the heat required to melt? 7,200. What is the heat required to melt per unit volume? 10. So this is 720, can think of, friends, what? Mm cube. Please check it is correct. 720 mm cube. Simple question, friends. ठीक है ना, 720 mm cube is correct. Yes, very good. Yeah. Next, one more technique please look at. This is with respect to projection welding. Previous one is spot welding, this is projection welding. In projection welding, 3 projections are welded at a time with the voltage of 2. Resistance welding voltage is very less and current is very high. 2 volts is correct only. Assuming contact resistance of 300 micro ohm for each projection, the rate of heat generated in kilojoules per second at the contact is. Okay, look at here friends. This is just like this one. Let us say we are considering projection welding. Okay, how many projections are there? 3. 1, 2, 3 projections. If I supply the current will be divided into 3 parts. So the 3 resistance will take the current. The current is divided into 3 parts, and that current is used for melting of the 3 nuggets. Each nugget resistance is what? 300 micro ohm. So here we need to, please think of friends, here this is like this. If we consider 3 resistance are there and we are going to supply what? The current. So R1, R2, R3, each resistance is 300 micro ohm. Now, so I am going to find out equivalent resistance. Equivalent resistance. What is R equivalent will be equal to R by 3. R equivalent will be equal to R by 3. So what is R by 3? I can say 300 by 3. It will be equal to 100 micro ohm. 100 micro ohm. Projection welding. If you touch this 2 electrodes in contact with the workpiece, along with this electrode, current is passing through this particular 3 nuggets at a time. So the current is divided into 3 parts friends. You have to consider parallel circuit. It is not a series, it is a parallel circuit when we need to find out equivalent resistance concept. Okay, now he is asking what is the heat generated. Please observe, heat supplied or heat generated will be equal to I square RT. The units are so many joules. And is asking joules per kilojoules per second. So this time I will make it in this direction. So that heat generated per given time will be equal to I square R. What are the units here? Joules per second, or so many watts. The time I am going to divide left side friends, so that you are getting right side is what? I square R. He has not given current, he has given voltage. So I will use the concept this one friends. What is that? V equal to IR. So I equal to V by R. So I square equal to V square by R square. So if you substitute this one friends here, I square is V square by R square into R. It will be getting cancelled. V square by R. V square by R we are going to consider here. So what is a V square? 2 whole square. 2 whole square. Resistance is what? R. R here 100 micro ohm. 100 into 10 power minus 6 into 1000 I am going to consider friends, because he is asking kilojoules per second. Kilojoules per second. Heat generated per given time, this is kilojoules per second, that I am going to divide it by 1000. So this answer is 40 kilojoules per second. 40 kilojoules per second. Kilowatt. Yes, very good. 40 kilojoules per second or kilowatt is correct. 40 kilojoules per second or kilowatt is the correct. Most of them are giving correct answer, right? Right. Next we will discuss one theory question friends here. The correct statements pertaining to friction stir welding. Friction welding or friction stir welding. Friction stir welding, flats workpieces we will consider, and we are going to rotate what is called what? The pin. A tool will be rotated between the 2 workpieces. It is a solid state welding technique. Okay. Intense heat generation will be there because of what? Friction. Intense heat generation is there because of what? Friction. Heat affected zone is not formed. We have discussed. Due to intense heat generation, up to certain zone, there is a chance of small heat affected zone will be formed in friction welding and friction stir welding. Okay. So not formed, that's why it is Wrong statement. Heat affected zone is formed. It is used for joining of flat workpieces, correct? It is used for what? Flat workpieces here. Now if you consider friends here, this is a two workpieces I am going to consider here by fixing here, and between the two workpieces we are going to plunge a rotating pin will be plunged between the two workpieces, so that joint is formed here. It is used for flat workpieces, it's correct. Dissimilar materials cannot be joined, wrong. It can be used for joining of dissimilar materials also. Dissimilar metals can be also joined. Melting of the base metal is not involved, it's correct. We are not melting the base metal, it is a solid state welding technique. So due to heat generation, the metal here will be in semi-solid, it may be formed, but it's not converting to liquid form. We are not melting the material, right? Maybe heating up to red hot condition it is possible, but we are not melting. So melting of the base metal is not involved, it is a correct statement. So B and D will be correct. B and D will be correct. Good, good, good. B and D will be correct. Yeah. Next ones here. Which of the following welding techniques heat flux is more? I think it is a simple question only. Heat flux means amount of heat supplied per unit area. Heat supplied per unit area, power per unit area we can consider, that is so many watts per mm square. Heat supplied per second we will consider, friends. Heat supplied per second, so many watts per unit area. Heat focused on the workpiece per unit area is called what? Heat flux or energy density. It is maximum for which material, friends? Here laser beam welding is correct. अरे कैसा जी LBM है ना, LBW? अरे यार not plasma arc welding, laser beam welding है ना, LBW, laser beam welding है ना. How it is plasma arc welding? After laser beam welding we can say plasma arc welding. So it is 20,000 degrees centigrade na? Laser beam welding still more, you can think of here 25,000, heat generation is more. So I can say, friends, heat flux is laser beam welding is greater than plasma arc welding is greater than submerged arc welding is greater than TIG welding. Heat flux is more in laser beam welding. Still if you want to write, I can write electron beam welding. Electron beam welding is very high. Heat flux is very, very high in case of electron beam welding. What is the 2-4 here? Heat flux is more, it is a multiple choice question na? Multiple choice questions. LBW is greater than plasma arc welding. LBW will be greater than plasma arc welding. Okay. Here 25, it is 20,000 only. Okay, right. Then next we can think of, friends, match the following with respect to defects. Defects in welding. Defects in welding. Gas porosity is formed because of trapping of the gases in the joint. Trapping of the gases in the joint. A4. Hydrogen embrittlement. Hydrogen embrittlement because of diffusion of what? Hydrogen gas into this base metal. Diffusion, right? Hydrogen gas into the base metal, that is B3. Next C. Lack of fusion, please, I'm sorry. Lack of fusion is what? Insufficient heat input. Yeah, lack of fusion and penetration, that is insufficient heat input, C1. Splashing, please observe. Splashing is what we can consider arc blow. Liquid metal from the weld pool will be getting splashed onto this base material. It will be getting solidified. Spatter will be formed. Splashing. The splashing can be possible because of arc blow also. Deflection of the arc, no? We have discussed this, please. So 4312. 4312 is correct. Yes, very good. 4312. 4312 is the correct answer. Okay, simple question with respect to defects. How to write, this is a welding defect and the cause of the defect, right. Next we will discuss the questions related to forming, metal forming. We will discuss some of the questions, friends. Yeah, one theory question please look at. Cold working, hot working, first we are discussing now. Working of the metal above the recrystallization temperature, below the recrystallization temperature. Okay, which of the following are the characteristics of a cold working process? It is MSQ. Please observe. First one, good surface finish and accuracy can be obtained, correct, because there is no heating of the material. If you start heating the metal and you are doing working above the recrystallization, metal oxide formation will be there, right. Due to oxide formation, surface finish will be getting reduced. It is hot working and there is no heating, that's why there is no heating of the metal, oxide formation nahi hota hai. Shrinkage is also not taking place, that's why accuracy is also very high. Dimensional accuracy, surface finish, both are good in case of cold working when compared to hot working. First statement is correct. Less forces are required, it is not correct. Because of strain hardening, strength of this workpiece metal is increasing. We need to apply more force in case of cold working when compared to what? Hot working. Mean flow stress will be more in case of cold working when compared to hot working. Cracks will be formed, yes, correct. Why cracks will be formed? Due to strain hardening. If you apply more amount of external load, amount of deformation is less, internal stress will be developed, that leads to crack formation in case of, right, in cold working. Strength and hardness will be getting what? Increased. Due to strain hardening. That strain hardening is dislocation pile-up. Due to dislocation pile-up at grind boundaries, strength and hardness will be getting what? Increase in case of cold working, because there is no recovery and recrystallization in cold working. It is there in case of what? Hot working. Okay. So this one, what is the answer, friends? Here A and C are correct. A and C are correct. अरे D कैसा होता है सर? A and D ना? I see D also there. Right, sorry. A, C, D correct. A, C and D. A, C, D. Yes, yes, very good. A, C, D. Yeah, now you can think of, friends. Please look at this question. The true stress, true strain relationship for engineering metal is sigma T equal to 300 epsilon to the power n, where epsilon is a true strain, n is a strain hardening exponent. Right? Flow curve equation. If the material necks at the true strain of 0.3, necking will be takes place at a true strain of 0.3. At necking, at maximum loading condition, at neck formation, we know that a true strain will be equal to strain hardening exponent. That will be equal to 0.3. ठीक है ना? That will be equal to 0.3. Ultimate tensile strength of the material. What is the ultimate tensile strength? We have to find out. So we know that, friends, here sigma true stress will be equal to sigma or ultimate stress will be equal to 1 plus E, we can consider 1 plus E. True stress, ultimate tensile strength, this is a engineering stress, it is not true stress, it is engineering stress. Sigma ut means engineering stress. 1 plus E, what is a small e? Small e is engineering strain. What is epsilon? True strain. True strain. Engineering strain. True stress, engineering stress. Okay. So if you want to find out here, friends, sigma ut, first I want to find out sigma t. Sigma t will be equal to 300 into epsilon 0.3 whole power 0.3. It is a condition, friends. We can derivation also for this, we can make it. At maximum loading condition, true strain will be equal to strain hardening exponent. At neck formation at maximum loading condition, this is the condition you have to assume, right? So from here, what is our true strain? Please tell me. True stress. What is the true stress? True stress will be equal to 209.054 megapascals. Then we need to find out 1 plus E. Okay. So true strain will be equal to ln 1 plus E. So here this is 0.3 be equal to ln 1 plus E. So 1 plus E I am directly finding here. 1 plus E is how much we are getting? 1.3498. 3498. 1 plus E. Okay. So if you look at here, now in this formula, sigma T is there. Sigma T is how much we are getting, friends, here? 209.054. Sigma UT we have to find. 1 plus E value is 1.3498. 1 plus E value I am finding. From here, ultimate tensile strength, that is engineering stress, ultimate stress or ultimate engineering stress will be equal to how much? 154 point, yes, very good, 154.87. 154.87 megapascals. 154.87 megapascals. Correct? Gaurav Pandey, 160, please, how you are right? Yeah, we will move to the next question. 154.87 is correct answer, right? Next question. Can you please look at, this is a rolling question. A 5 mm metal strip is required to be hot rolled to 4 mm thickness. The width of the strip is 100 mm. Flow stress of the sheet metal and torque per roll are 250 megapascals and 5000 Newton meter respectively. Then roll diameter is. Please look at, friends, generally we know this formula. Generally questions are coming in roll separating force calculations, power calculations, generally questions are coming. It is a reverse of that. Okay. Now we know that, friends, here please observe, roll separating force will be equal to, now we can think of an sigma naught flow stress, sigma naught multiplied by the, we can think of what what is that, projected area. AP is projected area. So sigma naught projected area is what? Width multiplied by projected length. Width multiplied by projected length, LP. LP is what? Projected length. Projected length. We know that, friends, projected length LP will be equal to R delta H, where R is the radius of the roller. Delta H is what? H naught minus HF, the amount of reduction or draft. Amount of reduction H naught, initial thickness to final thickness, is called delta H. Amount of reduction, or we can say amount of draft, we can consider. Okay? This one. Now here this is a roll separating force. If I know the roll separating force, then I am going to calculate the torque. Torque equal to force multiplied by arm length. What is the arm length, friends, here? 0.5 times of LP, because it is a hot rolling operation 0.5 times of LP, cold rolling operation 0.45 times of LP. LP is a projected length we are going to consider. So torque equal to force multiplied by the arm length will gives what? Torque. If you know the torque, then the torque is for single roll. So if you want to calculate the power, what we can say friends here, and 2 times of torque multiplied by omega will gives what? The power. 2 times torque multiplied by omega. Force into velocity we can't use in case of rolling, because the direction of the force applied and we can say velocity direction both are not same. Force applied and the roller velocity both are not same in direction. So power equal to force into velocity we can't use in case of a rolling. That is a 2 times torque multiplied by omega. This is a torque for single roll we have to consider. Okay. So he has given torque, this one. From here we need to find out what? From projected length we need to find out what? Radius. Right. So in this particular equation, if you consider friends, right, what you can say, torque equal to force. Force is sigma naught B projected length multiplied by 0.5 times of LP we can consider. So torque is 5000 Newton meter. So 10 power 3. So Newton mm I am going to consider. Sigma naught flow stress is given 250 into B, width is 100 mm. Width of this workpiece is given, and this is R delta H. Delta H kitna ji here? Delta H will be equal to 5 minus 4, it will be equal to 1 mm. 5 minus 4, it will be equal to 1 mm. R delta H, this one, right? So multiplied by 0.5 times of R delta H, R into delta H, that is 1. So R under root R, it will be gives what? R. So R we are getting is how much friends here? 200 mm, right? 200 mm radius you are getting, and is asking what? Diameter. Diameter will be equal to 400 mm. Right. So in power calculation also this formulas please try to remember. What is the angle? Right. What you can say, angle of bite formula, right? Amount of draft. Power calculations, right? This is very, very important. General questions are coming friends with respect to this one. Okay. 400 mm, not 800 mm. Why you are getting 800 mm? Most of them are getting 800. No. No. It is 400 mm only. Please check it. Please check it, my dear friends. $400 mm only. Please check the answer. You are getting 800 mm. Most of them are getting 800 mm. Please check the answer. R equal to 400 you are getting. Okay. Radius is 400. Okay. I will check it. This is 400. Okay. Please accept this one because in calculation I made mistake. Right. Radius is 400 and diameter is 800 mm. Okay. Fine. Yes. Okay. Fine. Right. So please check it friends here. All right. This question. The next you can observe here. Right. This forging, these problems are very, very, very important. Please observe it. Most of the cases you are going to confuse with this one. I will give very simple way how to solve these equations. Right. Question is more lengthy, but answers are very, very simple. Okay. But here we have to remember formula for sticking length in rectangular bar forging. In case of axisymmetric objects also, we have made a derivations also for this one in the class. That is sticking length formulas we have to remember. Okay, na? Right. A 20 mm, 160 mm copper plate is forged between two flat dies to a final size of 10, 40 and 160 mm. Determine the maximum forging pressure assuming the coefficient of friction between the job and the die is 0.2. Take flow stress of the metal as 70 megapascals. Okay, my dear friends, forging is please think of we need to consider which type of equations we have to use. It's a plane strain condition. Width direction there is no deformation. Which is the constant value? That is what? Width. So if you consider initial dimensions are 20, 20 and 160, and final dimensions are how much? We can consider 10 mm and 40 mm and 160 mm. So which dimension it is constant, that is what? Width. It is called what? Width, which is constant is what? Width. Width is constant because it's a plane strain condition. Width is constant, initial and final width is same. Next, please observe, if the dimension is reducing, please look at, if I am applying the compressive force, dimensions is reducing means height is reducing. So this is a height we can consider, friends. This is a height. If you are applying the compressive loading, height is reducing, which is increasing? Length is increasing. So this length generally we are considering 2L na. I think if you remember properly, right, this is 0, from this direction it is L, this direction it is L. We are considering this is a strip here at a distance of, this is a dx at a distance of x we are going to consider here. Okay, na? So 2L we can consider here. So length is getting increased. So initial length is this one, friends, right? This is we can consider L0, you can put here. So final length is this one. So in forging load calculations, always we have to use final dimensions. Forging load calculations, always you have to use final dimensions. Okay, right. So we can think of final dimensions. Final height is 10 mm. Final length 2L will be equal to what? 40. So from here L will be equal to what? L will be equal to 20 mm. It is a rectangular bar forging. What is the sticking length, friends? Here sticking length XS will be equal to, we can think of here L minus H by 2 mu ln 1 by 2 mu. This formula you have to remember, there is no option, right? So here L we can consider, friends, here what? 20 minus H 10 by 2 mu. Coefficient of friction is what? 0.2. 0.2 ln 1 by 2 into 0.2. So how much you are getting this value, please tell me. XS sticking length कितना होता है? Sticking length is minus 2.907. Minus 2.907 mm, friends. So you are getting negative means there is no sticking. Look at, friends, XS will be equal to negative. No sticking. No sticking. What will be there? Only sliding. XS is negative. XS is less than 0. No sticking, only sliding will be there. If XS is greater than L, only sticking, sliding is not there. If XS is positive, we can say what will be there? Sticking and sliding both will be there. Okay, na? This concept already we have discussed. Now here only sliding condition is there. Sliding condition mein what is the pressure? Pressure distribution is 2K e power 2 mu by H into L minus X we can consider. Where pressure is maximum? Generally at the center. If X equal to 0, pressure is maximum na? At the center pressure is maximum. So if X equal to 0, P equal to P max. P equal to P max is asking maximum pressure equation. This equation we have to remember, friends, at least maximum pressure sticking sliding condition, because sometimes questions are coming. Production they are giving. One time they have given the question, right? This is also maximum pressure kitna hota hai. Okay? Right. At X equal to 0, P is equal to P max. So P max will be equal to 2K. Here K is flow shear stress. Flow shear stress is sigma naught by root 3. Sigma naught by root 3. What is sigma naught? 70. 70 by root 3. X equal to 0 I am putting, friends, in this equation here. X equal to 0 putting, just you are getting L. So e power 2 into mu 0.2 by H, that is a 10 into L. L is what? 20. L is 20. P max. What is the maximum pressure? 179.88. Very, very good. minus 2.9 is the sticking length. Up to this you have to be more cautious, right? 179.88 you are getting. P max, I am writing here friends, please observe, 179.88 megapascals. 179.88 megapascals. Okay. Now I think this is a little bit extension I have given friends, but up to this sticking length, up to sticking length question is coming. What is a sticking length? What type of friction will be there? Sliding, sticking, or both sliding, sticking, both will be there. This type of questions can be expected. I have given little bit more friends here, because even sometimes production they have given maximum pressure, sometimes force also has given. Integration of the pressure, right, we will get what? Pressure multiplied by area. Pressure multiplied by area will give what? Force. Forging force, if you want to calculate, we can do that also. Okay, na? But up to this I can think of it is a little bit more. No, I can say integration means it is still more complex. Okay, right. This is with respect to what? Billet friends, that is a rectangular bar forging. If you look at here, this I am considering it is a axisymmetrical forging. Axisymmetrical forging, you can think of a circular disc of lead radius 150 mm and thickness 50 mm is reduced to a thickness of 25 mm by open die forging if the coefficient of friction is 0.25. What type of friction will be there between the die and the workpiece? Here is asking what type of friction is there. What type of friction will be there? And you can observe friends here. Initially he has mentioned what we can say, initial radius is 150 mm. And initial thickness means height h naught will be equal to 50 mm. And final, please think of here r we can consider is how much, and thickness, this one is what, h equal to 25. Okay, so we know that volume will remain same in plastic region. So what is that? Pi r square equal to pi, sorry, this is volume pi r square multiplied by h naught equal to pi r square multiplied by height. So pi will be getting cancelled, r naught square will be equal to 150 whole square into h naught will be 50 mm, be equal to r square multiplied by 25 mm. What will be the value of r? Right. So first we need to find out r value friends here. 212.13 mm. Now here friends, in this particular case, if you consider sticking radius formula, there are two formulas are there. One is von Mises theory, second one is what, Tresca's theory. So you can observe here, in case of von Mises theory, that is sticking radius r is equal to r minus h by 2 mu ln 1 by root 3 mu we can consider. This is according to von Mises theory. And you can substitute these values friends here. Now here he has not given, it is generally if nothing is mentioned you can consider von Mises theory. And even if you are using Tresca's theory also, you will get the results will be same only, because sticking radius will be thoda change hota hai, but positive negative based on that we are discussing what type of friction na. So there is no change in that, values thoda change hota hai. We will discuss that point also. So if you consider here rs will be equal to r 212.13 minus h, final h कितना होता है 25 by 2 into mu is 0.25 ln 1 by root 3 into mu. What is the mu? 0.25. So how much you are getting, friends? RS here you are getting is 170.28. 170.28 mm. It's a positive. Positive means what? Both sticking and sliding दोनों रहेगा. Both sticking and sliding both will be there. Sticking and sliding both will be there. Sticking and sliding both will be there. From 0 to 170 it is a sticking. From 170 to 212 it is sliding. Both sticking and sliding, both frictions will be there here. Sticking and sliding both will be there here. Because you are getting RS is positive value. Same story. RS will be negative value, only sliding hota hai. RS is greater than R, only sticking will be there. If it is a positive value, both sticking and sliding both will be there. And you are getting sometimes, friends, right? What is that? This is von Mises theory, no? If you consider what is right, R minus h by 2 mu ln 1 by 2 mu, this is according to what? Tresca's theory. According to Tresca's, this is a formula. R minus h by 2 mu ln 1 by 2 mu, it is Tresca's theory formula. So in Tresca's theory formula, you can also give 212.13 minus height. Height is how much? 25 by 2 into 0.25 ln 1 by 2 into 0.25. If I am using this formula also, friends, RS here, you are getting the answer here is 177.47. 177.47 you are getting. Here also positive value means both sticking and sliding both will be there. But radius will be slightly changing here. It is you are getting how much? 170.28. Here 177.47 you are getting. But both the cases it is positive only. So positive means we can say sticking and sliding both will be there. Very good. Both sticking and sliding both will be there. Yes, very good. Excellent, excellent. Both sticking and sliding will be there. So that is the option you have to consider. So if nothing is given, you can use von Mises theory. Okay. Sometimes they are asking the question, for example, what is the sticking radius? If they are asking sticking radius means definitely they will give what type of theory we have to use, whether we have to use von Mises theory or Tresca's theory. They will mention the problem so that we can use corresponding formula. So up to sticking radius and sticking length, these formulas you have to remember. There is no option, friends. Sticking radius, sticking length, sticking radius we have to remember in rectangular bar forging and axisymmetric object. दोनों case में you have to remember. ठीक है? Right? Yes, very good. 177.47. It is also positive. Both the cases sticking and sliding only it is coming. ठीक है ना? Right. Is this question is clear? Please check it. Right. Determine the values of the strain hardening exponent for a metal that will cause the average flow stress to be 3/4 of the final flow stress after deformation. He is asking what is the value of strain hardening exponent. Strain hardening exponent. So generally we know, friends, flow stress equation sigma F equal to K e power n. Sigma F equal to flow stress equal to K e power n, where K is a strength coefficient, epsilon is a true strain, n is a strain hardening exponent. Strain hardening exponent. So we need to find out this one. And some of them are getting doubt. Sir, what is the difference between true stress and flow stress? True stress and flow stress, both are same only. True stress and flow stress, both are same only. See, beyond yield point, up to yield point, it is elastic deformation. Beyond yield point, the plastic deformation. In the plastic deformation, the stress we are going to measure is called true stress. But the true stress will be given in the form of exponential form, K e power n. Right? In exponential form, that's why it is given flow stress. Stress required to flow the material, it is called flow stress. It is given by flow curve equation. But this flow curve, flow stress or true stress, both will be same only. And we know that friends, average flow stress will be equal to K epsilon n by n plus 1. This formula we have derived in the class. Average flow stress. When strength coefficient and strain hardening exponents are given, we will find average flow stress. But as given the problem friends here, sigma average stress will be equal to 3/4 of flow stress, sigma F. It is given the problem friends. This I am not giving, it is given the problem. So what is the concept behind this one? You can look at closely. Let us say drawing operation you can consider. Okay, this is one friends here. This we are doing drawing operation through a die. This is a die. Initially this we are pulling the material friends in this direction by applying tensile loading. Okay. Now here if you consider initially this is sigma y. Initially the stress required to deform the material is sigma y. Beyond sigma y, yield strength plastic deformation will take place. And if you consider here, it is a drawing operation, let us say cold drawing operation, wide drawing operation. If you consider, strain hardening will be there. So that's why if you apply the force initially above this yield strength, if you are applying this force, we can deform the material. So the stress will be getting increased. When you deforming the material, stress required to deform the metal will be getting what? Increased. Stress required to get this deformation will be getting increased. Maximum stress will be coming what? Sigma F, that is flow stress. See, if you are applying the force beyond the sigma flow stress, that is flow stress, now the maximum reduction can be takes place at flow stress. If you are applying stress is beyond this flow stress, there is no deformation, the wire will break itself. It will break, wire will break it. Because maximum stress will be sigma F, that is a flow stress. If you are pulling the material, stress will be getting increased due to strain hardening. Maximum stress is flow stress. What is the minimum stress is sigma y. So here in between the stress is continuously increasing from sigma y to sigma F. Then we are finding what? Sigma average we are finding. Okay. So what is this one? Sigma F. So questions are coming. Maximum reduction can be possible at which stress? Sigma F. Drawing stress will be equal to sigma F at maximum reduction. समझ में आता है ना? This one. This concept you can see. Initially sigma y, maximum stress. Then we are finding average stress. So average stress equal to 3/4 of sigma y we are going to consider. Now you can think of average stress is what? K e power n by n plus 1 will be equal to 3/4 of sigma y, sigma f is K epsilon power n. K epsilon power n. From here we need to find out n value, that strain hardening exponent. So this numerator, this two will be getting cancelled. So from here what we can consider, 4 equal to 3n plus 3. Okay. So 3n will be equal to 4 minus 3, 1. So n equal to 1 by 3, that is 0.33. N equal to 0.33. Strain hardening exponent is 0.33. Okay. This concept please here. Now general friends, in drawing we are discussing maximum possible reduction and ideal case is 63%. Next, drawing formulas, drawing stress, drawing force required, power required, formulas are there. I have given the problem, please think of here. Initially sigma y, beyond sigma y deformation will start. Maximum stress is sigma f, that is flow stress. Good. Next, in extrusion process you can observe this question. In extruding a cylindrical billet of length 150 mm from an initial diameter of 25 mm to a final diameter of 20. Assuming flow stress of the metal is 250 megapascals, estimate the pressure required to overcome the container friction. It is a forward extrusion process. Nothing is mentioned, it is a forward extrusion process. Then look at friends here. This concept is like this. We are providing a container. Here we can have a die. Through the die, this workpiece metal is coming here. So this is the, we can think of what, billet. Okay. So this is we can think of, friends, here the plunger, and the plunger will be moving through the ram, and this is given length, container length is given. So this is a die, this is a die we can consider, friends, through which the workpiece will be coming out. Actually we are calculating extrusion force by applying here, extrusion force is there. So we, through, when the workpiece is passing through the die at the contact of this billet and this die, there is a possibility of friction will be there, right? That we are considering, friends. Die angle alpha, that we are considering. But here we have an extra in case of forward extrusion. Kya hota hai? If when you are moving this particular plunger in this particular direction, this is a billet, no? You know, if you are moving, billet is moving in this particular direction. When the billet is moving, billet will be in continuous contact with what? Container. This is a container. Okay, na? So when the billet is moving inside the container, between the billet and container some friction is there. Between the billet and this container some friction will be there. That is in case of forward extrusion only it is there. Indirect extrusion it is not there. Backward extrusion it is not there, because there is no movement of the billet. If I apply the force, the extruded part is coming in opposite direction. In indirect extrusion, that's why there is no container friction. Container friction will be there only in case of forward extrusion. To overcome this container friction, how much is the pressure required? We need to calculate. How much is the pressure required to overcome the container friction? Now that is in case of what is called direct extrusion. It is around 30% of it. The container friction, when the pressure required will be around 30% of total stress in case of extrusion will be there. So 25 to 30% will be there. Okay, right. So if you want to calculate the pressure required, we are applying the pressure on this particular plunger. So pressure required to overcome the container friction multiplied by the area. Pressure is acting at which area? Please think of, this is a diameter you can consider, diameter of the billet or diameter of this particular workpiece. Initially we are applying the pressure, initial area we have to consider. Pressure required pi by 4 d square. Pressure multiplied by area means we can get force. Okay, this will be equal to, what is that? Please think of, between the container and this billet we have a shear stress will be there, no? Shear stress because of the friction, right? Shear stress will be developed. Shear stress multiplied by what we can consider? Shear stress multiplied by shear area we have to consider. Shear stress multiplied by shear area we have to consider. Shear stress is, I will consider flow shear stress. In elastic deformation, shear stress tau s. In plastic deformation, it is a flow shear stress K value we have to consider, that is sigma naught by root 3. K multiplied by shear area, that is pi dl I am going to consider. Let us say, friends, a cylindrical workpiece. What is the shear area? Pi d multiplied by L. Pi d multiplied by L will be the shear area, where this plunger will be in, we can say the billet will be in contact with what? Container. That shear area we have to consider, that is pi dl. Now if you simplify this one, pressure required to overcome the container friction will be equal to 4kd by what we can say 4kl, sorry, lk by d we can consider. Sorry. (4kl by d) we are going to consider, and we are considering, friends, k equal to sigma naught by root 3 flow shear stress. K is flow shear stress. Flow shear stress. So pressure required to overcome the container friction is 4 multiplied by k sigma naught by root 3. What is this? 250 by root 3 I am going to consider into length. Length is length is 150 mm by d. Diameter is, initial diameter we have to consider 25, because we need to, in extrusion process, what is, we are applying the pressure at the initial diameter. Okay, so 3464. What is the value? 3464.1 megapascals. Correct na? Please check it. 3464.1 megapascals. Correct. pressure required to overcome the container friction. So in case of forward extrusion, if you are calculating the stress, the extrusion stress, for which you have to add this pressure required to overcome the container friction. Indirect extrusion, it is not required. Okay, please check this one. This concept is important. Generally extrusion, all calculations part you are doing. Apart from this, extra question I have considered this one. Yeah. Then you can think of, friends, here punching and blanking operations case you can say. A circular disc of 50 mm diameter is produced by blanking operation. Radial clearance is what? 0.0 mm. C equal to 0.1 radial clearance. Diameter clearance of 2C will be equal to what? 0.1 into 2. It is a 0.2 mm. Okay, na? This one. It is which process? It is a blanking operation. In blanking operation, which is same? Blanking operation, die is exact. So D will be equal to how much? 50 mm. Die is same. But clearance is provided on where? Punch size. Punch size will be equal to, you can think of, friends, this is D minus 2C plus allowance. Allowance means a factor of safety, friends. We need to consider factor of safety, right? Because more you can say sticking will be there, then we will consider allowance here. So D is 50 minus 2C, 2 into C, C value is 0.1 plus allowance kitna hota hai? Die allowance is how much? 0.06. 50 minus this one. Then you can tell me what is the value? 49.74, correct? Yes, directly given, friends, clearance here, radial clearance. But if you want to calculate, sometimes clearance is let us say 3% of sheet thickness, sometimes they will give 3% of sheet thickness, sometimes they will give, or otherwise if they are not given also we are considering 0.0325, right, T times of root of tau s we are considering. This formula also we can use. If not given, you have to use this formula. But generally they will provide, GATE examination they are providing. ESE we have to remember this formula. 49.74, correct. It is a blanking operation where die is exact, punch size clearance has to be provided. In punching operation, punch is exact, clearance is provided on the die. Okay, D plus 2C. And sometimes this is one aspect. Next they are asking, for example, what is the shear force? Fs maximum, if you want to consider shear stress multiplied by shear area. Shear stress multiplied by shear area. Okay, if you know the Fs. Now if you want to find out work done will be equal to Fs maximum shear force multiplied by punch travel distance, that is PT. Punch travel distance PT. Work done equal to Fs shear force maximum. Without shear, force is maximum, Fs maximum. P is punch penetration, percentage of penetration. T is the thickness of the sheet material. Now in blanking operation, punch is less than the die size. In blanking operation only, punch is less than what? Die. Yeah. In we can think of punching operation, punch is exact, clearance is added on the die. So die size is more because we need to allow the sheared component. We need to allow the sheared component in case of punching operation. Right? This one. Punch is always less than die, correct? Is correct. Okay? Right, next we will move to the next one, friends, here. Right? Please observe, friends, this question. Determine the percentage of reduction in punching force for punching a hole of 40 mm diameter in a 2 mm thick metal strip of if 2 mm shear is provided on the punch. Shear strength of the metal is 400 Newton per mm square and assuming 50% of penetration. 50% of penetration, P equal to 0.5 penetration. And here friends, please observe, we need to consider some conditions friends here. We are discussing S is greater than PT, if S is greater than PT, or trapezoidal is there, force versus displacement will be trapezoidal, force versus displacement is trapezoidal. Third one is cutting is done by using blades. Cutting is done by using blades. In these three cases also, we are using work done will be same, no? Fx maximum into Pt will be equal to Fs into S, where S is the shear. These three cases we have to consider. Here in this particular case, S is greater than Pt or not, we have to check. S is 2 mm. What is Pt? Penetration is 0.5. 2 mm, 0.5 into 2 means it is 1 mm. So it is greater. S is greater than what? Pt. S is greater than Pt. S is greater than Pt. समझ में आता है ना? If S is greater than Pt, first condition is satisfying here. That's why I will use this particular formula, friends. Fs maximum into Pt, penetration is what? 0.5 times of 2 will be equal to shear force multiplied by S. S is what? 2. Because I am not calculating shear force, friends. If you are calculating shear force, time is taking more. I am not calculating shear force. Without calculating shear, because we need to consider what is a percentage reduction in punching force is required. No? So if you want to consider here, if you simplify, Fs equal to Fs maximum by what? 2. So with shear, Fs will be, Fs means cutting shear force with shear. Fs maximum means without shear. It is Fs is Fs maximum by 2 means how much reduction hota hai? 50% reduction is there. 50% reduction. So he has given this, friends, you can calculate Fs and Fs maximum percentage reduction. You can calculate, you are getting 400 because shear strength is given. If you are calculating that, it will take more time. Single step you can use this formula. Because S is greater than Pt, this one you have to use. 50% reduction. 50% reduction. Okay, na? So this concept, if you are using this concept like this, friends, you can save the time. So you can attempt one more question. So you have to use this one. So if you are calculating Fs maximum, if you are calculating Fs percentage change in this, you are calculating 3-4 steps are required, then time taken is more. Okay, all right. Please check it. Please check it. This concept is clear. Yeah. Next, we'll think of it. This is a very interesting question. Please read the question. Please attempt. How many are going to attempt this question? Yeah. The minimum radius to which a sheet of thickness 4 mm can be bent if the percentage reduction in area of the metal in tensile testing is 25%. Percentage reduction in area will be 25%. We know that, friends, in bending, true strain developed will be equal to 1 by 2r divided by thickness plus 1 we are going to consider. समझ में आता है ना? True strain equal to 1 by 2r radius by thickness plus 1 we are considering. See, if you are bending the sheet material, outside fibers are under tension, inside fibers are in compression. See, if we consider inside fibers, you are getting negative, means true strain will be negative, means it's a compression. Tensile means it is a positive. So true strain equal to 1 by 2r by t plus 1, where we need to find out what radius we have to find. But here we need to find out what true strain. How to calculate the true strain from this concept, friends? He has given percentage reduction in area. So percentage reduction in area, percentage reduction in area will be equal to A naught minus AF by A naught. A naught minus AF by A naught, percentage reduction in area. This will be equal to 0.25 will be equal to 1 minus AF by A naught. So from here AF by A naught will be equal to how much, friends? This is 0.75 we are getting. AF by A naught. So if you want to find out first true strain, ln A naught by AF, you can find now generally ln, this is 1 by 0.75. So what is the true strain from this equation? True strain कितना होता है? True strain is 0.2877. 0.2877 is the true strain. From this area we are getting this one, friends. Now here if you consider here 0.2877 will be equal to 1 by 2 into radius. We need to find out na minimum radius required. Thickness is how much? 4 mm plus 1 we can consider. So what will be the R value you can consider? What will be the radius? Minimum radius is कितना होता है? Yes, very good. 5 mm. 4.9516. You can consider, friends, 4.95. So you can make it R equal to 5 mm. It's a good question, friends. This formula I think we have discussed in the class in bending. The true strain developed in bending operation is given by this one. Okay, please observe this concept. Okay, right. The last problem, please observe. I think theory question, friends. What type of stress will be developed in this one? Some theory questions have given, friends. In case of coining operation, friends, coining means it is just like a forging operation. Keep these two workpieces between the die and apply the compressive force. Compressive means we can think of, friends, in coining operation, compressive loading is coming. One is a C. Next, punching operation, shear force will be there. Punching operation, shear force will, stretch forming, what is that? Tension will be there. In stretch forming, tension will be there, B. Fourth one, deep drawing process. Deep drawing process, what? Tension and compression will be there, A. Both tension and compression will be there in case of deep drawing operation. समझ में आता है ना? CDBA, very good. This question, friends, here. CDBA. Last question for today, right? Application, friends. With respect to application, this we can, I think you can easily say. Forging can be used to produce what? Connecting rods, 1B. Impact extrusion can be used for collapsible tubes, right? 2 will be C. Right, rolling operation we can produce what? Rails, 3D. Fourth one, welding, pressure vessels can be fabricated. Submerged arc welding, pressure vessels can be fabricated. BCDA, very good. BCDA. A simple question only. Now last question, this one. Which of the following defects are correctly matched with their corresponding process? Defects in case of sheet metal, casting, I have mixed here, friends. Blister is what? Casting defect, na? Liquid metal is projected into this surface. We are expecting a projection on the top surface of the casting. It is a correct statement only. Next, pipe defect is an extrusion. If there is no impurities, surface oxide layers are penetrate into the center of this workpiece, we are expecting pipe defect. Orange peel effect, correct? Deep drawing process. In case of deep drawing, maximum deformation will be at the punch corner radius. If coarse grain structure will be there in the workpiece material, coarse grain structure is there, due to maximum deformation at the punch corner radius, rough surface can be produced at the punch corner radius on the cup. In the cup, rough surfaces can be produced, that is called orange peel effect, that is a deep drawing. Spreading, rolling. Spreading means when this workpiece will be passing, width will be getting what? Increased. width of this particular workpiece will be getting increased. W0, W1. So W1 minus W0. Change in width is called what? Spreading. Right. So the spreading is coming when the width to thickness ratio, width of this particular workpiece will be less. If the width of this workpiece will be less, there is a chance of spreading chances will be there. Spreading chances will be there. Very good, very good. All are correct. All are correct. A, B, C, D, all are correct. So with this I am closing, friends. I will not take much time for you. I hope you have enjoyed this session and this session is useful for you. And I am wishing that on behalf of GATE ESE and myself, I wish all the students appearing for GATE examination to be a great success. Right? Be confident. Don't lose the hopes. Don't lose the hopes in between. Up to this examination, you continue the preparation. Right? You continue the preparation. Revise the things. Don't read extra things nowadays. Just up to examination, just you can revise the things, brush up the things. If possible, you can attempt 1 or 2 tests. Right? So be confident, and with more confidence you can attempt the exam, so that results will be fruitful, better results can be possible. Don't get tensed, don't get nervous. Okay na? You continue the preparation up to the GATE examination, you will get better results. Okay na? So with this I am going to conclude. Thank you very much. And friends, if you have any doubts, I think already I have given my WhatsApp number if it is there with you, or with this WhatsApp number, if you have any doubts, you can contact me through WhatsApp number, so that if you have any doubts also we can discuss. Even Telegram channel also, if you have any doubts you can ask, then I will give the reply. Right? This one. I hope you have enjoyed, friends. Right? Yes, very good. Yes, very good, very good. Thank you very much, friends, for your comments, and wish you all the best, a great success in your career. Go ahead. Okay, thank you very much.